Hello good people, I'm going to talk about polygons. These are closed two-dimensional shapes made of straight lines. The word polygon stems from ancient Greek and it means many corners or many angles. In a regular polygon, all sides are of the same length and all angles are of the same magnitude. Note that not all polygons are necessarily regular polygons. Let me explore a few. I'm going to start with triangles. In a scalene triangle, all sides are of different length and all angles are of different magnitude. In an isosceles triangle, two sides are of the same length and two angles are of the same magnitude. In this example, I have indicated that these two angles have the same magnitude of theta. How could I indicate that these two lines are in fact of the same length? I can do that by adding perpendicular bars across the sides that are of equal length. The next triangle is an equilateral triangle. Here, all sides are of the same length and all angles have the same magnitude of 60 degrees. If I absolutely insisted, I could draw vertical bars across all three sides to indicate that they are indeed of the same length. Lastly, among the triangles, we have a right-angled triangle. In this type of triangle, one angle is 90 degrees. Let me move on to quadrilaterals. Quadrilaterals are shapes with four sides, and there are 7 main types. Let's start with a humble square. Here, all sides are of the same length and all angles of the same magnitude of 90 degrees. In case of a rectangle, opposite sides are parallel and of the same length, and all angles, once again, are of the same magnitude of 90 degrees. In case of a parallelogram, opposite sides are parallel and of the same length, while opposing angles are of the same magnitude. The fourth quadrilateral is a trapezium. For something to be considered a trapezium, one set of opposite sides needs to be parallel and the adjacent angles need to add up to 180 degrees. What are the other three quadrilaterals? I'm so glad you asked. We have a rhombus, where all sides are of the same length and the opposing angles are of the same magnitude. Next, we have a kite. For something to be seen as a kite, adjacent sides need to be of the same length and one set of opposing angles needs to be of the same magnitude. Finally, we have an irregular quadrilateral. Here, all sides are of different lengths and all angles have a different magnitude. Before I bring this fantastic journey to an end, let me explore a few more of the regular polygons. Here we have a pentagon, a hexagon, a heptagon, an octagon, a decagon, and a dodecagon. In case you're wondering what happened to the 9-sided nonagon, well, 7, 8, 9. Recall that the sum of all angles within a triangle is 180 degrees, while the sum of all angles within a quadrilateral is 360 degrees. What about these polygons? I have written the sum of all of their degrees beneath these shapes. There is a pattern here. For each extra side, or if you like, for each straight line, we add another 180 degrees. It turns out that sum of all of the angles within a regular polygon is equal to the number of sides minus 2 multiplied by 180 degrees. Let me quickly test this out on a triangle. A triangle has 3 sides, 3 minus 2 is 1, 1 multiplied by 180 degrees is 180 degrees. Let's try this on an icosagon, a 20-sided polygon. I'm going to say that S stands for sum of all the internal angles, and it equals number of sides, in this case 20, minus 2, multiplied by 180 degrees. 20 minus 2 is 18, and 18 multiplied by 180 is 3,240 degrees. Now you may have noticed that this icosagon that I have drawn is starting to look a lot like a circle. What if we had a polygon with an infinite number of sides? In other words, what if we had an apeirogon? An paragon approaches a circle, but it is not an actual circle. Now, why is that? Let's look at our starting definition for a polygon. It is a two-dimensional shape made of straight lines. Circles are not made of straight lines, and therefore circles are not polygons. And while we can entertain an idea of a polygon with infinite sides, it would never truly become a circle. Some things, much like that date with that person you've been eyeing off from a distance, are not meant to be. That is all for now, and I will see you on the flip side.